Okay, I'm going to work this one out. I see still some students make mistakes on this. So let's see the first one. We're given a function f of x equals to negative 4x squared plus 3x minus 1. So this function is called a quadratic function, right? Quadratic because of this highest degree is 2. We call this leading term. Leading term, so it gets a quadratic name. Also, we call this a polynomial function degree 2 because the highest exponent is 2. So that's the degree of this polynomial. Anyway, so that's just a name. For this one, we want to evaluate f of negative 2. In the function, the input is x. So how do we understand this function? X is just a variable, right? So in our head, we think x is just a variable, it changes, right? So maybe better to think it's an input. So function is like a machine. We input x, it outputs x squared multiplied by negative 4, outputs the input square multiplied by negative 4, then plus 3 times the input minus 1. So now the input is negative 2 for this one, for A. So we just push the input, right? Push the input into this function machine. We still have negative 4. Now times the negative 2 squared, because the input is not x anymore, it's negative 2. Then plus 3 times negative 2, right? But the input is negative 2. Then minus 1. So as you can see, we don't change the numbers. Negative 4 stays, square stays, 3 stays, negative 1 stays. So all those numbers stay there. The only thing changes is the x, is a variable, depends on the input. Then we do the calculation, right? Negative 2 squared is negative 2 times negative 2. Negative times negative become positive. So any number square, any negative number, when you square it, become positive. That's in real number system. So I have negative 4 times positive 4. Negative 2 squared is 4. Then positive 3 times negative 2, that's negative 6. Then plus 1. Negative 4 times 4, negative 16. Minus 6 plus 1. So how do we do this calculation? We have two negatives, right? So negative 16 minus 6, you think as you spend $16, then you spend another $6. How much money you spend in total? So you add those two numbers, but you keep the negative sign. So that's negative 22. Then negative 22 plus 1. Well, plus 1, negative, you spend $22, but you're given $1, right? Well, you have $1 in your pocket, something. So one is negative, one is positive. So that equals to negative 21. So what's the step actually here? Let me show you the step, which is this negative of 22 minus 1. Let me keep this step. So 22 minus 1 is 21, but we keep the negative sign. That's how we get a negative 21. All right, let's see B. B now the input is A plus 2. We have no idea what A is, and we don't care, right? The input is A plus 2. Just follow the pattern of the function. So that equals to negative 4 times the input, which is A plus 2 squared, input square plus 3 times the input, A plus 2, then minus 1. You see here, negative 4 still here, raised by square still here, 3 is here, negative 1 is here. The only thing changed is A plus 2, the variable. The input, because the input now is A plus 2. So x before this is x, now it's A plus 2. Okay, then we'll just do the, calculation, all right? And we have perfect square. Let me start from here, need more space. So a -4, now a plus 2 square is called a perfect square. A plus 2 is a binomial square. So what do we have? We have first one square, which is a square, plus 2 times the first one times the second one, we have 4a, plus 2 square, which is 4. Then plus 3 times a is 3a, 3 times 2 is 6, then minus 1. Then we multiply -4, distribute -4 inside the parentheses. We get a -4a squared minus 16a minus 16 plus 3a plus 5, right? 6 minus 1 is just 5. Then we see if we have like terms to combine. A squared, no like term, right? Just -4a squared. That's our leading term. Then we have -16a plus 3a. That becomes -13a. Then we have -16 plus 5. That becomes -11. So that's it. We still get a function, but now we get a function in terms of a, not in terms of x anymore, right? Let's go to C. F of a plus f of 2. So let's just evaluate f of a. What's f? Well, let's read f of a first. The input is a now. So every place of x just change to be a. Plus 3a minus 1. So -4a squared plus 3a minus 1. Now let's evaluate f of 2. F of 2 equals to -4 times 2 squared plus 3 times 2 minus 1. Then we just calculate. Okay. So we get 2 squared is 4, -4 times 4, -16. Then plus 3 times 2, 6. Then minus 1. Well, 6 minus 1 is 5. -16 plus 5, -11. Right, now we add those two together. So f of a plus f of 2. We get -4a squared plus 3a minus 1 plus -11. Well, combine like terms. So -4a squared has no like terms. It stays as that. 3a doesn't have like terms, it's just 3a. Well, -1 plus -11 becomes -12. That's it. That's f of a plus f of 2. So it's a function in terms of a. Let's see D, f of -x. So now the input is -x. So -4 times -x raised by square plus 3 times -x minus 1. Now simplify. -x squared is positive x squared. So we get a -4x squared. Then positive 3 times -x, that's -3x, then minus 1. So f of -x is still a function, quadratic function in terms of x. Okay, let's see 2. Difference, we want to find this difference quotient. It's a difference quotient. First is a difference, right? So this difference between f of x plus h and f of x. Then quotient, because it's a division, divided by h. So it gets a very honest name, difference quotient. So let's calculate. So we have f of x already. So let's just calculate f of x plus h. The input is x plus h, so we do 2 times the input x plus h squared minus the input, which is x plus h, then plus 5. Then we calculate perfect squares again. So 2 times x plus h squared called perfect square. So x squared, first one squared, plus 2 times the first one times the second one. That's 2 times x times h. Then plus second one squared, which is h squared. Then minus x minus h plus 5. Right, we'll get rid of this parentheses for x plus h. Now we distribute 2 into the 3 terms. We have 2x squared plus 4xh plus 2h squared. Then minus x minus h and plus 5. Combine like terms. 2x squared has no like terms, so that's 2x squared. 4xh has no like terms, that's 4xh. 2h squared has no like terms, so 2h squared. Then, oh, actually there's no like terms, right? You see every term is different. X squared, xh, h squared, x, h, 5, so no like terms. Now let's subtract. Let's write down f of x underneath, so we can subtract. I can subtract vertically. F of x equals to 2x squared minus x plus 5, right? Let's do the subtraction. So f of x subtract, let me use pencil first. We saw 2x squared minus 2x squared is gone. Minus x minus negative x is gone. 5 minus 5 is gone. So I left the f of x plus h minus f of x equals to 4xh plus 2h squared minus h, right? So only those 3 terms left. Now we divide by h. Now actually, we see h is a common factor of these 3 terms. So let's factor out h. Then we have 4x plus 2h minus 1, okay? Then once we finish this, let's divide by h. Let's put, so we divide by h. We see h divided by h. H is a factor in the numerator, h is a factor in the denominator. H divided by h becomes 1. So the answer for this one is equals to 4x plus 2h minus 1. And that's it. So that's the difference of quotient. It's just 4x plus 2h minus 1. Let's see this one. This one actually I did on YouTube already, but anyway, let me do one more time. It seems like it's a troublesome, this question, because this is a rational function. Well, let's do the same thing. So f of x plus h equals to, well, 1 over the input, right? So 1 over the input. What's the input? X plus h. X plus h. It's better to think the input instead of x, because x is a variable. Okay, so f of x plus h equals to 1 over x plus h. Because the function is the input is x, output is 1 over the input. So when the input is x plus h, the output is 1 over x plus h. Now let's subtract f of x plus h minus f of x equals to, I'm going to write this way, okay, 1 over x plus h. You know my notation is, okay. Yeah, right, just subtract those two functions. Then what do we need? We need common denominators, right? What's the least common denominator? We need to find out least common denominator. Least common denominator is x times x plus h. So which means we want to multiply by 1 for each one. And for this one, we want to multiply by x plus h divides itself. X plus h, we want to multiply x plus h in the numerator, x plus h in the denominator, right? Actually, let me do a little bit tough. So this one, we want to multiply x plus h in the numerator, and we want to multiply x plus h in the denominator. X plus h in the denominator. Well, x plus h just 1, right? It's multiply by 1. So similarly, we multiply x over x for this one. Of course, we want to put parentheses around it. So when we multiply by two factors, two terms, so let's put parentheses around it. Right? X over x also 1. So when we multiply by 1 with any expression, that's okay, because we don't change the quantity of the expression. So 1 over x, we multiply x plus h divides itself. Now we have a denominator of x times x plus h. The second one, we multiply by x, also we have the same common denominator, x times x plus h. So once we have that, let's subtract. We see the numerator, we have x. Okay, I'm getting my pencil. We're subtracting from this to this, right? To the, oops, my arrow to this. So we basically we have x, this x, subtracting x plus h. So x minus x is gone. Those two become 0. Then we just minus h. So after the calculation, this left with negative h over x times x plus h. So in the numerator, we have negative h. In the denominator, we have x times x plus h. Now we divide by h. Remember difference of quotient? We have the quotient part. So subtraction is a difference. The quotient is a division divided by this h. So we divide by this h. 3 layers of division, right? So this h actually we could just multiply by this. When we have 2 layers, let's see, half divided by 3. This you can think like half apple shared by 3 people. So each one gets 1 over 6. So we just 3 layers of fractions. We just multiply the 2 denominators. So 1 over 6. So half apple shared by 3 people. How many apples each one get? Each one get 1/6, right? Apple. Okay, so we have denominator. H is a factor in the denominator. H is a factor in the numerator. So that cancel out. So in the end, the answer is negative, because we have negative sign there, right? The numerator is 1. The numerator is 1. The denominator is the common denominator, x times x plus h. Let me draw a line here to make a fraction. So that's it. That is the differential quotient for function f of x equals to 1 over x. Okay, let's say 3. 3 is asking the domain of the function, right? Domain means what can the inputs be? right? So we have f of x. So what kind of value works for such x? So that's the domain of this function. We're working with real numbers. So real numbers means under the square root sign, this is called a radicand. So the radicand 3x plus 9, radicand 3x plus 9 has to be greater than or equal to 0. However, because it's in the denominator, so it cannot be 0. So we just have the radicand greater than 0. All right, then we solve for this inequality. So we move 9 to the other side of the inequality, becomes -9. Then we divide by 3 on both sides to get x greater than -3. And we are asked to write in interval notation. So that means open parentheses starting from -3 up to positive infinity. Right? Infinity. I don't have the sign, so I'm writing in words. And that's it. That's the domain of the first function. Right? So only limitation is the square root sign and also is in the denominator. So we have to see the radicand, the expression under the square root sign is called a radicand. 3x plus 9 has to be greater than 0. We solve for this inequality, so get x has to be greater than -3. Use the interval notation, that means starting from -3, but not including -3. So we use the open parentheses up to infinity. That's the domain of the first one. Let's see B. B, first we have to consider the numerator, because the radicand x minus 3 has to be greater than or equal to 0 because it's in the numerator, so it can be 0. It's okay to be 0. But then the second thing we have to consider, x minus 5 cannot be 0. Right? If x minus 5 equals 0, that's not allowed in mathematics. That's illegal in mathematics. So we have to consider both. So this one is tricky. All right, so solve for the first one, inequality. That means x has to be greater than or equal to 3. Well, the second one is saying x cannot be 5. X can be any number, but just not 5. Not 5. So combine those two. Let's use the interval notation. We're starting from 3 with bracket because 3 is in the solution set. Starting with 3 bracket, so 3 comma up to 5, but not including 5. So we use this union notation to get rid of 5. Then up to infinity. Up to infinity, right? So that's how we get rid of this 5. So from 3, including 3, we use bracket, up to 5, close parentheses, ignore 5. Then union, open parentheses, 5, ignore 5, up to infinity. All right, so this is the domain of the function in B. Okay, I hope this helps.